Solka, Ivy Masters Learning Center and IvyMasters.com, and today we're going to look at the 22nd question from Digital SAT Test 3, Module 1. Number 22 reads, x minus 29 equals x minus a times x minus 29. Which of the following are solutions to the given equation where a is a constant and a is greater than 30? You've got your Roman numerals. So we're going to go over three different approaches here. One is a strategy. We're going to use our answer choice. That's the simplest way to do this. The second one, we're going to use Desmos. And the third one, I want you to stick around to see if you could solve it the hard way algebraically. Okay, first off, using our answer choices. So when it's asking for the solutions, in other words, it needs the value of x. So let's test out Roman numeral 1. A. Could a be the value of x? If we just plug it in, we've got a minus 29 equals a minus a times a minus 29. And then we've got a minus 29 equals 0 times a minus 29. And 0 times a minus 29 is just 0. So we get a minus 29 equals 0. You add your 29 to both sides. And here we cancel. So we get a equals 29. Well, it says that a's got to be greater than 30, so Roman numeral 1 is false. Since Roman numeral 1 is false, you can eliminate a and b and d. They're all gone. You've got your right answer, C. Now, you couldn't have predicted that just testing for one Roman numeral would get your answer. And if you did, for the sake of time, I'm not going to prove Roman numeral 2 and 3 true, but they are. You could try them out. You plug a plus 1 in for x, plug 29 in for x. If you just plug 29 in for x, you get 0 on both sides. That's all real solutions. And a plus 1, if you plug it into the left side, you get a minus 28. And if you plug a plus 1 into the right side, in this parenthesis, your a plus 1 gives you 1, and then you plug a plus 1 in here, and then you get a minus 28 as well. And a minus 20 equals a minus 28 again, all real solutions. So I guess I just did that, but I didn't write it down. Okay, second way to do it, this is, I'd say, the second best way to do this particular problem. You wouldn't necessarily know this, but you could use Desmos. And when you plug it into Desmos, you look at it and you're like, crap, I don't see anything. So what do? Anytime you plug into Desmos and you don't see it, you've got two different sides of the equal sign, just plug them in one at a time. So what I'm going to do is I'm going to cut that, get rid of my equal sign, and paste it here. And it gives me a slider, so I'm going to put that slider in. All I see is one line, though. I should see two. I've got a red and blue, so we got to zoom out until we see two. Boom, now we see two. But I don't see both intersection points. Now keep in mind the solution to a system of equations is an intersection point. So let's see what our solution is here. We've got a solution, and this question is asking for the solution, this value of x. So it's going to be the x part of the intersection. The solution is 2 and 29. So when we go back to the question, 2, where does that come in? Well, notice my a is set to 1, and the solution is 2. So what worked? A plus 1 worked here. A plus 1 worked. A did not work. How do I know that? Well, check it out. If a is 1, I get a 2, and I get a 29, so that didn't work. So A's gone. Roman numeral 3. Is 29 true? I got 2, I got 29. So it looks like 29 is true. Let's make sure, let's move this. So now if my a is 2, one intersection is 3. It's still a plus 1, and the other intersection is still 29. So 29 and a plus 1 still work no matter where you move this slider, so you know you have your answer. Okay, last way we're going to solve this question is we're going to do it algebraically. So what would I do? You could FOIL the right side. So then I get x minus 29 equals, I get x squared. And Outsides I get minus 29x. Insides I get minus ax. And then for the last term I get plus 29a. So I'm going to subtract x from both sides. And I'm also going to add 29 to both sides. So it cancels here. Why did I do that? Because quadratic should always be set equal to 0. What I wind up with is x squared minus 30x. And I know I wrote plus 29 over here. Notice I can't combine that with any other term. But I'm actually going to write it over here. Why am I writing it over there? Because it looks like that's something that I might be able to factor. And then I'm going to write the rest of it. What didn't I write yet? I didn't write this part. Minus ax plus 29a. And that all equals 0. So now let's factor this first piece. 0 equals, I need two numbers that multiply to give me a positive 29 and add to give me a negative 30. If I did x minus 1 times x minus 29, that'll multiply to give me a positive 29, add to give me a negative 30. That is factored. And I'm going to pull out the greatest common factor to the right. It's minus a, and then what do I get? I get x minus 29. Now notice that the x minus 29 is both on the left side and the right side. So now what I'm going to do, and this is something you've probably done before, it's a little complicated, but it's factored by grouping. So in other words, I could write this once, so 0 equals x minus 1 minus a, and then I could write this once. I could write x minus 29. So now, to finish it, I got to set each of those parentheses equal to 0. So x minus 1 minus a equals 0, and x minus 29 equals 0. Then I add 29, add 29. I get x equals 29. And then here, if I add 1 and add 1 and add a, then I get my x alone over here. X equals a plus 1. A plus 1, 1 plus a. So once again, Roman numeral 3, 29, Roman numeral 2, a plus 1. Thank you for joining us today. If you like this video, click like. You could share it with someone who has difficulty with, it's just a hard question. If there's any question you'd like to see answered from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. To see the short videos, go to YouTube, IB Masters Learning Center, go to the playlist, find your tested module number, just test 3 module 1, and then you'll find that the shorter videos are just below these longer videos. Make sure you click subscribe and check out this other complicated quadratic one. Have a great day.